Please remind me, someone every day, to say, make sure, sir, are you recording? You know, like, because I want to make sure that these videos are available to you later. So what I'll do is, since I'm recording, I can always have a record of like who had their video on, who didn't. And like I said, I mean, you don't have to do it, and you don't have to do it every single day. If you have one of those days where you just didn't get much sleep and you just don't want to be on camera, that's cool. I understand. But it really helps me. I hope that makes sense. Another thing I'm going to be doing is, as I'm working through problems, just like I would in a normal class, I like to turn around, you know, face the classroom and say, hey, what do you think of that? And ask for feedback and call on you, kind of put you on the spot. So what I'm going to do is, I have a list of your names here on one of my screens. And every day I'm going to have the computer randomly shuffle the class. And then when I get to a point where I want to ask the class something, I'm going to just go off that first name on the list and I'm going to call on you. Now, if you don't respond, that's okay. Okay. I mean, like, if your video's off and you're not there or something, you know, I'll make a little note of it. No big deal. But if it happens consistently, where every time I call on you, you're never there, then I'm going to consider that lack of participation. Now, if I call on you and you don't know the answer and you're like, I'm not sure, then that's all I want to hear, is I'm not sure. And it's not to embarrass you. It's not to try and humiliate you. It's just to try and engage you and keep you interested in what's going on. All right, that sound okay? No? Okay. See, it's good whenever you have your video, y'all can just nod, and then I feel better about things. Okay, what else? What else should we discuss? How about our calendar? Again, I went through this in the video, but let me just show you the schedule. What the heck? How did that happen? There we go. Okay, so this is our schedule, and this is available to you in Canvas. And it just shows kind of day by day what we're going to be going through. And you can see today we're going to do an introduction. I'm kind of telling you what my expectations are. And then we're going to start a section on fractions and applications of fractions. And then you have a homework assignment that goes with that. All right. Now, homework in this class, I'm not going to collect, okay? You're going to just do the homework and do it on your own. And since there's no checking on it, you're kind of, I'm trusting you that you're going to do the work, right? I mean, this is college, and that's also something I should really point out here. This is not a high school class. Even though it's kind of our easier version of college algebra, I expect that I'm dealing with adults here, all right? So if I give you a homework assignment, the expectation is that you do it. If you just show up and you watch me do problems all day and you sit there and go, oh yeah, I got that, and never practice on your own, you're just not going to be successful. I mean, that's the way math is. You have, it's not a spectator sport. You have to get engaged. You have to try the problem. So the homework is there. We work through day by day, and then eventually we'll have an exam. And we have on our schedule 2 exams, 3 exams, 4 exams. We have 4 exams, and then we have a final. All right. Now, let me tell you how the exams are going to work. The exams, you're going to show up just like this, and then you're going to have to stream your video of you working on the test. So I'm going to email you the test. Everyone's going to get the test, and they're going to write down the problems. We'll go through it later. We don't have to get into all the details right now, but the main idea is that you're going to be on camera live taking the test, and then you have to somehow get all your handwritten work to me electronically. And so that means that your camera has to be set up properly. And I talk about this in that video. Here's a picture. If you can see, this is me, a still picture of me at my desk. And this is what I'm going to expect on the exam days for everyone here to be able to do. So you might want to practice this, not right now, but you might want to practice this between now and the first exam. Getting your camera set up in a position where I can see you and your whole work area. And I know some of you are gonna be like, well, I can't because my camera's on my computer. Well, what you're gonna have to do is probably download the Zoom app on your phone and then use your phone as your camera and put that behind you or something like that. Again, we'll have time to practice this and get ready for this. But I just want everyone to know, like, that's the way the exams are going to be administered. You're going to be just paper and pencil, and then you're going to send me your work, and then I'm going to grade it, and you will get partial credit. You know, if you start a problem out correctly and then you just kind of mess up something in it, you'll get partial credit. It's much better than like multiple choice tests where it's like right or wrong, right? So it's to benefit you that I will be looking at all your work. Are there any questions on that? I know that I'm leaving a lot of details out, but are there any like general questions on the assessment or the way that the test will be administered? Okay, let's talk about, again, I don't want to go through this whole entire thing, but let's talk a little bit about the syllabus. Of course, everyone's here in this meeting, so you already know how to get here. I introduced myself. I also have my cell phone numbers available there for you if you need to get in touch with me. And then I have office hours. So there are times, in fact, today, immediately after this class, well, not immediately after, at 11 o'clock, I'll have a Zoom meeting where I'm just gonna sit in there, and if you show up, I should be there. It's from 11 to 12:30, and I'm just there to answer questions. And that's open to all my students. So all my students from all my classes can come to this. And I have those meetings on Tuesday, Thursday. I also have a few meetings on Monday, Wednesday. All right. What you need for the class is this packet. And you can purchase it from the bookstore, and they do curbside, but I also make this packet available to you electronically. I already have it right here. You just go to our homepage, class packet, you click on that, you can download it to your computer. You don't need it as a hard copy. You don't need a physical copy of it, but you need to be able to access it. Okay, so you need, as I'm working through it, you need to be able to see what I'm doing. And your homework is in that packet. So technically it's free, right? Because you don't have to buy anything. It's right here. Back to the syllabus quickly. So you also need a calculator. Now it says that you need this particular calculator. The only reason that we give a specific calculator is because when I'm showing students how to do something, if we're all using the same calculator, I can tell you what keystrokes to use. And every calculator is a little different. So let me just say this. If you already have like a basic scientific calculator, you don't need to go out and get a new one. You don't have to. But if you are having trouble getting certain things to work out on your calculator, you're going to have to maybe contact me, come to my office hours, something where I can tell you what keys to use, or like for your calculator, how to type things in properly. All right. You also, of course, need a computer and a phone, but you're here. So that again is where I'm talking to you about. The camera needs to be placed during the test in a certain way. All right, so how's your grade broken down? As you can see, it's all exams, right? There's no homework grade, there's no quiz grade, there's just the exams, that's it. And unfortunately, that's the way it's going to be because of this COVID and this remote learning type thing. Now, I will offer bonus, right? I've already offered one, you keep streaming your video. But there will be other opportunities. I'll think of things that will help you out. We may do activities where we break into groups here in Zoom, and I give you problems to work on, and I give you participation bonus or something like that. So there will be ways to kind of increase your grade, but you just need to make sure you're here and participating and actively engaged in things. All right. Any questions? Okay, so please read through the syllabus, go through all the details of it, and let me know maybe next class if you have any additional questions that you didn't have today. You sure there's no questions?
I have a quick question.
Yes.
Is there a calculator that we have to get?
Well, okay, that is the calculator
Okay.
that I highly recommend, but if you already have a scientific calculator, like I said, you can use that.
Okay.
You don't have to get that one. You may not use your phone on the tests as a calculator. So most likely you're going to be using your phone for your camera. So either way, even if you're not, nobody can have their phones out during the test.
Okay. Thank you.
Mm-hmm. Any others? Any other questions? Okay, let's practice something real quick. I'm going to put you all into breakout rooms, okay? So what that means is I'm going to randomly group you into rooms together. I'm going to put like 4 or 5 people in each room. And I want to see if while you're in the room, y'all can figure out how to raise your hand and ask me for help while you're in the room, okay? So here we go. Let's see how this goes. Where is it? There they are. Okay. So this is just trying to show you some of the tools that we have here available to us. Okay, you should get an invitation and then go ahead and join that room. Okay, so I hope that within that room you were able to see that there's a way to ask me for help. I couldn't jump around to all the rooms. I went into a few of them, but it's kind of like if I ever put you all in there and you're working on something, y'all are stuck, then you have the ability to ask me to come and jump in there with you. And then you also have that white share screen button that you can use to, you know, if any of you have a tablet or something, you could write things down. So I just wanted to show you that functionality. What's really kind of telling about that feature is when I do that, sometimes I'll do it like randomly. I'll say, hey, let's go into the breakout rooms. And then everyone will join their breakout rooms. And then there'll always be like 1 or 2 people that don't join. And the reason why is because they're not there. They're here, but they're like in a different room in their house doing something else. And so they're just sitting there, you know, never joining in the breakout room. And that just shows me that they're not participating. So please be aware that if you ever come back to your computer and, you know, it's just you there, it means you didn't, you know, you weren't there when I put people in breakout rooms. So, okay, we ready? You ready to do some math? No, you're not. Come on. Or are you? Yes, you're excited about this, huh? All right, so before I actually do like real math, I just want to talk about one more thing, and that is, why is it that we have to do this? Like, I think it's a question that a lot of people have. Why do I need to take this class? You know, my major is this, whatever. And when am I ever going to need to be able to solve a quadratic equation or factor a polynomial, or like, when will I ever need to do that, right? Isn't that a question that maybe you've sat with and thought yourself, you know, like, why do you need this? So I have two answers for you, okay? And you can take them for whatever you want. You have your own opinion. This is my opinion. So the first one is that, you know, college is like it's like a circus, you know, it's a bunch of hoops you have to jump through, right? Say, okay, jump through this hoop. All right, good job. Jump through this hoop, good job. And at the very end, they hand you a piece of paper. And you get that piece of paper, and then that piece of paper is supposed to help you go get your job or whatever it is that you want. I mean, that's kind of I don't like that response, but at the end of the day, you could look at it that way. You're just doing what you're being told to do, right? Now, the answer that I prefer, though, has to do with what college does for you in the big picture, right? So a lot of you don't care for math. Obviously, me in college, I enjoyed math, but there are certain courses that I had to take that I didn't like. English, I didn't like English. I didn't like reading. I didn't like writing papers, okay? There's a lot of things that I had to learn to do that I did not enjoy, but I had to do them. And the idea is that when you have that degree at the end of the road, you have your college degree, it's supposed to mean that you're capable of learning, okay? That you have demonstrated the ability to learn. And not only learn, but learn things that you don't necessarily have an interest in. And so you have this general basic knowledge of a lot of different things. There's an analogy, or kind of a picture that I like to use to kind of demonstrate what I'm talking about. So if you get a bachelor's degree, a Bachelor of Arts or a Bachelor of Science, a BA or a BS degree, then what that means is that you know a little, I apologize for my handwriting. I'm trying to get back into things here. You know a little about a lot. Okay, so you know a little bit about English, a little bit about history, a little bit about art, a little bit about math, a little bit about this, a little bit about that. And yeah, you may know a little bit more about your major, okay? But you've got this broad education, right? This broad knowledge. And then if you move on and get like a master's degree, a Master of Arts or a Master of Science, and what this means is that you know a lot about a little. So that's kind of like, you know, I got my master's in math. That means I know a lot about math. Don't ask me about English. Don't ask me about, you know, certain other fields. I know a lot about math, all right? And then if you were to move on and get a PhD, then that means that you know pretty much everything about one thing. Okay, so you're an expert. You are the person to talk to about this one particular thing. You are the expert, all right? That's the way I look at education. And so when we're talking about what we're doing here, we're just trying to broaden your knowledge and make sure that you're capable of learning. Because if somebody is going to hire you, they need to know that you're capable of learning. And the degree is what kind of gives that employer that confidence that they can go take. I like to give this analogy. Have you ever walked up to a brand new copying machine and had to make a copy of something, right? I mean, hopefully everyone has had that experience. If I'm your employer and I'm taking you, it's like first day on the job, I'm like, hey, here's the copying machine. Here's how you make copies. Here, do this, do this, do this. The employer's not going to want to have to teach you that 3 different times, right? Take you back. Oh, okay, let me show you again. Okay, 3rd time, I already showed you this. The degree is supposed to mean you're capable of learning. You can absorb something, process it, retain it, and then move forward. And so this is all about just training your brain to think a certain way. And so math, to me, is just a certain part of your brain we're trying to get the gears going and train to process. Follow steps, process the information, all right? That's my spiel on it. Let's get moving. Okay, so we are going to start off with the first topic in the packet. Here's our packet. There's a couple of stuff here. There's a couple of things here in the beginning that I'm going to skip through this preview. I'm going to skip through that because of time. And I'm going to get right into the fraction examples. And the way the packet works is that there's going to be examples and kind of an introduction to each section. So here's fractions. I'm going to try and work through as many of these problems as I can. I won't always be able to work through all of them, but I will work through enough that you can get the idea. And then after I get through these problems, then you have the homework section. You can see here it's homework, page 9, and that, from, remember back on the schedule, it said you had to do page 9 homework. This is your homework assignment. So I recommend that you do these problems for homework. And then when we come back next time, I will start the next section, order of operations. And then I'll go through that. And then you will have your homework for that. All right. So every class, when I come in and I start, the first thing I'm going to ask you is, do you have any questions over the homework? I'll give you an opportunity. If you went through any problems and you had trouble with them, then I will go over them right there in class. And if we get to a point where we're eating up too much of the time, then I will you know, recommend that you come to my office hours or something like that for help. Okay, so fractions. Let's start with fractions. So when we talk about fractions, we've all seen fractions before, but let's talk a little bit about what they are. And then we'll start doing the operations. And this is probably somewhat of a review. Like you've probably done this in the past, but it's probably been a while. So we need to actually make sure we understand any processes we learn here are going to carry through the rest of the semester. So we want to make sure we understand this, or we're not going to be able to move ahead. So a fraction, I like to think of like a candy bar. You know, this is one candy bar, let's say. And if we were to cut this into, let's say, 3 equal pieces, and we were to only take one of those 3 pieces, then we could represent that as a fraction, 1/3. So 1 is the one on top represents the parts that we take, parts taken, and then this is basically the parts total. So how many pieces did we cut it into? We cut it into 3. How many of those parts did we take? We only took 1 of them. So we have 1/3 of the candy bar. All right. Is that a concept that everyone understands? We could have cut that candy bar into 5 pieces, 4 pieces, 8 pieces, 100 pieces. Doesn't matter. The bottom can be pretty much any number that we want, except what? There is a restriction on a fraction. There is a number down there that we can't put. What number can we not put down there? Feel free to respond.
0.
0. Okay, so let's think about why you can't put 0 there. So let's say I try and write down 3/0. So that means I'm going to take 3 pieces, right? I'm going to take 3 pieces out of how many pieces? How many pieces should I have started with? 0, right? That's not possible. It's not possible for me to take 3 pieces if I don't have anything to start with. That's like me saying I'm going to have 3 pieces of a candy bar that doesn't exist, right? So that's impossible. Now, can we have it the other way around? So this is, I'm going to put here, we call this undefined. Okay, and the whole idea here is that we cannot have a 0 down there. That cannot happen, all right? Can we have it flipped over? Can we, does this make sense? So how many pieces are we going to take?
No.
We're going to take no pieces, but how many pieces was the candy bar cut up into?
3.
3. So it's kind of like we took a candy bar, we cut it into 3 pieces, but then we didn't take any of them. So how many do we have? Nothing, right? We have nothing. So 0 over 3 would equal 0. 3 over 0, this one is undefined. And then of course, 1 over 3 is just this idea of taking 1 out of 3 parts. Any questions on that?
No.
So 0 on top's okay, 0 on bottom's not okay. What about this? This always throws people off. What about this? This is known as an improper fraction. What makes this thing improper? What do you think? What do you think makes this thing improper?
Because the bigger number is on top.
Yeah, you've got a bigger number on top. So what does this mean? Like if we were trying to visualize this, this means we have a candy bar. How many pieces did we cut it up into? So look at the bottom number, right? That's how many parts we cut it into. We cut it into 3 equal pieces. And then how many of those did we take?
5.
5. So what we need to do is we need to imagine that there's actually another candy bar cut up into 3 equal pieces, and then we wound up taking 5 of those. So we took 5 of these 1/3 pieces. Now, you may be more familiar with this number. This is called a mixed number. Actually, I wrote that down. Yeah, that's right. Okay. So this is a mixed number right here. And what it is another way of representing this 5/3. So think of it this way. If I were to turn this into a fraction, what would that be? Just this over here. How many pieces did you take out of how many parts it was cut up into?
3 over 3.
Yeah, you took 3 out of 3, right? Plus, now here, how many pieces did you take?
2.
What's the
2 over
fraction
3.
that represents that picture?
2 over 3.
2 over 3, right? And if you put this together, what is 3 divided by 3?
1.
1, and then plus 2/3. And 1 plus 2/3 is this, 1 and 2/3. That's what that means. So improper fractions are fractions where this numerator, the thing on top, is bigger than the denominator, which is the thing on the bottom. If it's the other way around, then they're just called regular fractions or proper fractions. But anytime the top is bigger than the bottom, it's called improper. Okay, we will get more into this later. I just want to make sure we have a basic understanding of fractions visually. Now, what we need to be able to do is we need to be able to do a couple of things with fractions. So our goal here is to be able to multiply, divide, add, and subtract fractions. Okay, that's our goal. Now, if you go back and you think about when you were in grade school and you were learning numbers, what operation did you learn first? Like you learned the numbers, you learned how to count. What was the first operation that they taught you out of these 4 operations? Multiply, divide, add, and subtract. What did they teach you first? What's that? Addition, right? It's addition. That's what you learn when you're in grade school. You learn how to add numbers first, then you learn how to subtract, then you learn how to multiply, then you learn how to divide, right? But when it comes to fractions, we actually learn how to do the multiplication and the division first. And the reason why we do it is because it's easier than the addition and the subtraction. So we learn that first. All right, so let's talk about multiplying and dividing fractions, and I'm gonna do these one at a time. So let's say you're given 2 fractions, all right? Given A over B times some other fraction C over D. All right, so this dot in the middle right here represents multiplication. So if you're asked to multiply 2 fractions, how do we do it? Does anyone know the actual technique or way that you multiply 2 fractions together?
Don't you do like the
Go out on a
Cross
limb.
multiply?
What's that?
like the cross method, like A
Yeah.
to D? or-
Just across, just straight across. All you do is multiply the numbers
Like
across.
across, like the
So you just go multiply the A times C, and then multiply the B times D, and that's your answer. Okay, let's do a specific example next to this. Okay, so if I have, let's say, the fraction 3 over 5 times the fraction 2 over 7, and I wanted to multiply that, then all I would do is multiply the number straight across. So I would do the 3 times the 2 over the 5 times the 7. Now, a lot of times I'm going to be sitting here doing these multiplications and I'm just going to do them in my head. If you don't know what certain things multiplied together are, then you just need to have your calculator handy, all right? So 3 times 2 is 6, and 5 times 7 is 35. And this is the answer, all right? The answer is 6 over 35. Any questions on that? Multiplication is the most straightforward operation between fractions because all you're doing is multiplying across. Let's do another one. This one's going to be a little more complicated. Not complicated, but it's going to add one more little twist to it that's going to cause a little bit of an issue. Let's go 3 over 5, and let's go 4 over 9. All right, so we're multiplying 2 fractions together. So we're going to go straight across. Let's go ahead and do that. We do the 3 times 4, and we do the 5 times 9. And when we do that, we get 12 on top, and on the bottom we get 45. And we can box this answer. Now, is that answer correct? Does that look right to you? Does it look like I did that okay? Yeah, it is correct. But what it is not is what we call reduced. Okay, so it's kind of like this idea. Let me kind of come back to this in a second. If I write this fraction 4 over 8, 4 over 8 is a candy bar cut up into 8 equal pieces, of which I'm taking 4. And you can see, hopefully you can see from that picture, that that's the same as me taking half of the candy bar, right? Taking 4 out of 8 is the same as me taking half of it. So it's equivalent to me it's equivalent to me taking a candy bar, cutting it into 2 pieces, and taking 1 of them, and that would be 1 over 2. So somehow 4 over 8 and 1 over 2 are equal, right? They're equivalent fractions. So the way that I can determine that is by looking at the original fraction, 4/8. And this is where things get a little tricky. You have to ask yourself, right? You have to think through this, and you have to ask yourself, is there a number that goes into both 4 and to 8? So can you think of a number that divides into 4 but also divides into 8? So what number goes into 4 and 8 both at the same time?
2.
4.
4, okay. Does 2 go into both?
Yeah.
2 goes into both, right? What you want to try and do is find the biggest number that goes into both. So even though 2 would work, let's try 4. So you look at this 4 and you say, okay, 4 is kind of the magic number. 4 goes into that 4 one time, and then 4 goes into that 8 twice. And so that's how this fraction is reduced. Are there any questions on that? Okay, so let's go back over here to this answer that we had, 12/45. And let's see, was that reduced? Is there a number that goes into both of those?
3.
3 does. 3 does. Now, this may not be obvious to everyone, but it does. Let's try it. How many times does 3 go into 12?
4.
You can get your calculator out. You do 12 divided by 3. That would be 4. How many times does 3 go into 45?
15.
15 times. Okay, so let's look at this answer, 4/15. Is that reduced? Is there a number that goes into both 4 and 15?
No.
No, no number other than 1. But if you ever have 1, you just leave it alone. So the correct answer is 4/15. So if on a test I ask you to multiply fractions together and reduce, if I tell you you have to reduce, then the answer I'm looking for is 4/15. Now, could we have done this a different way? I know some of you have seen a different way of doing this.
Couldn't you have found like the greatest common factor of the denominators, or no?
Something like that, not exactly, we don't call it greatest common factor. What we could do is back here in the beginning, okay? What we could have done is we could have done the same thing where we're trying to find a number that goes into both, but we could do that for any of these numbers. So what I could have done is said, oh, look, this 3 and this 9, they both have a number that goes into both. There's 3, right? 3 goes into both of those. So I could have reduced that and said 3 goes into 3 once, 3 goes into 9 3 times, and then at that point, multiply straight across. And if I do it then, what would I get? If I multiply now straight across, get 1 times 4, that gave me the 4, and 5 times 3, that gave me the 15. You can do that either way. You can reduce it at the end, or you can reduce it in the beginning. It's up to you, but you just need to be aware of both techniques. Let's do one more. Okay, let's do one more, and then we're going to move on to division. Any questions? Remember, I'm recording all of this, so all of this will be available to you later on, right? All of these, if you need to go back and watch any of this. Okay, so one more example of multiplication. Let's see, let's go 4/15 times 3/8. All right, so let's try the first way, which is where we just go straight across. Okay, let's just do that and see how that works out for us. So if I go straight across, I'm gonna get 12 on top. And then what's that, 80, 120 on the bottom? Okay. Now, is that reduced? Is there a number that goes into both?
Yes.
There is a number that goes into both. What number?
12.
12, right? Now, sometimes if you can't see that number right away, here's something you can do. Like 12 and 120 are both even numbers, right? They're both even. They end with either like 0, 2, 4, 6, or 8. So if you know for sure 2 goes into both, you can just reduce it. Like 2 goes into 12 6 times. 2 goes into 120 60 times. And then 2 goes in again, doesn't it? To both of those? 2 goes into 6 3 times, and 2 goes into 60 30 times. And then you'd have to realize at this point that 3 goes into both of those. So 3 goes into 3 once, and 3 goes into 30 10 times. Now, that seems a little bit tedious, right? But would have been easier if we just noticed that 12 went into both. Would you all agree? Okay, now let's try it the other way. Let's go back to the very beginning and let's work with the numbers over here. I recognize that 4 goes into 4 once and 4 goes into 8 twice. Is that the only thing I recognize?
3 goes into 3 once and 2 15.
Yeah. 3 goes into 3 once and 3 goes into 15 5 times. If I do it that way and multiply straight across now, I get my 1/10, right? Straight from here to here. So there's different ways to get to that answer. I want you to work with the way that you're most comfortable with. Just be aware that there's multiple paths. Okay, any questions?
No.
So this is it. We should just have one exam for your whole grade for the whole semester, just multiplication of fractions, and call it a semester. Sound good?
Yes.
I won't argue with that.
Division. Okay, so division. Let's say we're given a over b, so we have a fraction, a over b. I don't like the way that looks. Let's say we're given a over b, but now we use this division symbol divided by c over d. What we have to do for division, okay, is convert it to multiplication. So I'm giving you the step right here, all right? What you do is you leave the first fraction alone, you change the division symbol to multiplication, but then you must flip over the second fraction. That's called the reciprocal. Whenever we flip a fraction over, it's called its reciprocal. So I had a student last semester who said something to the class to help people remember this that I hadn't heard. Maybe you have. It was something like keep dot flip. I think that's what she said. Has anyone heard something like that? Keep dot flip. So if you have division, what you're going to do is you're going to keep the first fraction exactly the way it was. You're going to replace the division symbol with a dot. Okay, so you're keeping, you're dotting, and then this fraction that was c over d is now d over c. So you flipped it. So that's the way you do division of fractions. You keep dot flip. All right. So let's do a problem. Let's do, as an example, 1/3 divided by 2. That'll be interesting to see what you do with that. So that's the problem. First thing that you need to recognize is that the number 2 is a fraction, right? Isn't the number 2 a fraction?
Yes.
What
there's
is
no
it?
one on the bottom.
2 over 1.
It's 2 over 1. So first things first, let's just make sure we understand that 2 is 2 over 1. So we are dividing two fractions here. And so what we need to do is we need to keep the first fraction, change it to a dot, flip the second one over, and then once we're there, we just do multiplication. So every division problem with fractions eventually becomes a multiplication problem. So I'm going to do 1/3, keep, dot, flip, and now straight across. Unless we can reduce something. Can we reduce anything here? I don't see anything that can be reduced. Right? Are you allowed to reduce this way, looking at those two numbers? Can you look at the 3 and the 2 and cancel there? Or does it have to be from top and bottom?
Top and bottom?
Top and bottom. That's the only way you can reduce. It has to be top and bottom. You can't go across the bottoms. Okay, but let's do our multiplication. So we multiply straight across. 1 times 1 is 1, and 3 times 2 is 6. And there you go. 1/6. That's weird, but that's what it is. Okay, let's do another one. How about 4/7 divided by 14? No, let's not do 14. Let's do 5/2. Okay, so what are we going to do?
You're gonna keep the first fraction and then flip the sign or like the symbol to multiplication,
Mm-hmm.
and then switch the last fraction to 2/5.
Oh, that. And now you run your multiplication straight across. So 8/35. And that doesn't reduce. The way that I know that this doesn't reduce is I go back and I look at this and I ask myself, like, does anything reduce out over here? Like, I can't think of anything that goes into both 4 and 5, and I can't think of anything that goes into both 2 and 7. So I know that that doesn't reduce. Now, here's something to be careful with. What if you went back to this and tried to reduce here? Then don't you have the 4 and the 2? Like 2 goes into both of those, right? You are not allowed to reduce fractions until after you've converted it from division to multiplication. So you have to be here. This is where you can reduce. Never try and reduce over here. Never reduce prior to the keep dot flip, all right? Never reduce. Okay, so let's go back and look at the packet real quick, and let's just see what are we doing, how are we doing on time here. All right, so what do you think here? This first one right here, you know what I'm going to do? I'm going to, let's copy this over. Go back to my notes here. Start a new page, throw these in here. Okay. So these are the examples that are in the packet. Okay, what about this first one here? Let me start this today. Let me pick on somebody, and I'm just going to go in just a random order here. How about Emily? Is Emily around? There's Emily. How's it going, Emily?
I'm good.
What's your major?
I want to go into education,
Education? What level?
kindergarten.
God bless you. We need people like you. I can't do that, but you know, I think it's a no, it's wonderful. I mean, I envy kindergarten teachers because they're so capable of dealing with small kids, and it's such something I can't do.
My mom's a kindergarten teacher.
Yeah. Okay. All right. Well, look, Emily, this first one, number 4, how you feeling about that? What do you want to do?
So I would simplify first. So
Okay.
the 4 and the 16.
Okay, let me do that. So you're saying to yourself, what number goes into both of those?
4.
4. So 4 goes into 4 once, and 4 goes into 16 4 times. So that's the way that you would approach it.
Yes.
I like that approach. I would have done it the same way. Yeah, because the numbers would have gotten really big had we not done this.
Yes.
And then, are you done, or do you want more?
The 9 and 3.
Yep, you can reduce this. 3 goes into 3 once, and 3 goes into 9 3 times, and then straight across, right?
Yes.
Okay. So your final answer, Emily?
Would be 1/12.
1/12. Okay, good. All right. See? So look, I'm not trying to embarrass you. Anyone here? It's just, I want everyone to feel comfortable here. And I want you to participate because I know you want to, right? You want to talk, don't you? Like, let's see, let me check Emily off. Where in the world were you? There you were. So I'm going to mark Emily as having participated. And that might help Emily out later on in the semester when she's like, hey, I just need, a little bit of bonus or something. You know what I'm saying? This participation, I will have a record of. Let's see. How about number 5? I'll let someone volunteer. Now that I've mentioned bonus, I should get volunteers left and right. Anyone want to volunteer? Okay, Sebastian, go ahead. What do you got? How would you do number 2? Or not number 2, number 5?
Okay, so I would, I guess, do the keep dot flip first.
Okay, so tell me what to write.
7/8.
Uh-huh.
Then times 9/2.
Okay.
And then it doesn't look. Okay.
So it sounds like you're looking to see if it reduces, right?
Yeah.
Okay, good. Everyone should be probably looking at that. Are there numbers that can cancel out here? And Sebastian, I think you're not seeing anything, right?
Yeah. So we're good.
Yeah, we're good. We just multiply across. So 7 times 9, 63 over 16.
Mhm.
Here we go. Who wants to take number 6 or 7? I'll let you choose. Anyone want to volunteer for 6 or 7? Sammy, I see your hand up. Go ahead, Sammy. You go by Sammy, yes?
Yes, Sammy.
Okay, go ahead, Sammy.
I would reduce the 21 to 18,
Okay, so what number goes into both of those?
3.
3, so it goes into here, what, 7 times? And here, 3 goes in there 6 times? Are you done?
No, the 16 and the 24, I would do 4.
4 goes into both, so 4 goes into 16 4 times, and 4 goes into 24 6 times. Is that what you did? Yeah?
Oh, wait, hold on. 8.
No, you're good. I like it. I like it because I think you just realized more goes in, right?
Yeah,
That's okay, though. You can do it again right now. What goes into both the 4 and the 6?
8. Oh, 4 and 6, 2.
So you could go again if you wanted to and go 2 goes into there twice and 2 goes into there 3 times. Like if you realize it after the fact that there was a bigger number, you can just continue or you can just start over with it. It's up to you. Okay, good. Now what?
Then multiply across.
Mm-hmm. So what do we have up top?
14.
14 over
18.
18. Yes?
Yes.
Okay, now, got to be a little bit careful here because we're not completely reduced. Do y'all see that?
Yeah.
So what we missed, and I missed it too, I didn't see it until we wrote the answer out, is that we also have a reduction that could have been done between that 2 and that 6. We could have said 2 goes into 2 once and 2 goes into 6 3 times, right? But it's okay because we can do it here also. We can at this point just put 2 and 2 goes into there 7 times, 2 goes into there 9 times, and we would get 7 over 9. Okay, any other volunteers? That was Sammy. Who wants to volunteer next? Anyone? What was that? I heard a beep. Was that someone? Did someone do that?
I just got an email, a school email.
So did someone want to volunteer or no?
Yeah,
Justin?
I do.
Okay, Justin
Caroline.
raised his hand, so I'm going to go with Justin. Okay, Justin, so I tricked you, Justin. Sorry. I want you to do number 9. All right? So I'm gonna help you because this was intentional. We have not talked about this yet. So does everyone see that number 9 is different than everything else? All right? And the difference is that those are mixed numbers, right? They're not fractions. They're mixed numbers. So what we're gonna do is I'm going to help Justin out with the first part. We have to be able to convert a mixed number over to a fraction first, and then we're just going to follow the procedure. So over here on the side, I'm going to practice converting. It's not the way you spell convert. Convert mixed to fraction. Okay, so here's how we do it. Let's start with the first one. It was 1 4/9. Does anyone remember how to do this? There's like a quick little method you use. Ashlyn, were you raising your hand? No? Oh.
Don't
Didn't
you
work?
like you do something with the 9 and the 1 and then the 1 and the 4?
Yeah, okay. So what we do is we take the number here, 1, and we multiply the 9. All right, so what's 1 times 9?
9.
9, okay. And then what we do, we keep that in our head, 9, and what we do to that answer is we add that number, 4. Okay, so we do 1 times 9 and then add 4. So what would that be?
13.
13. So this is going to turn into 13 over, now what do you put on the bottom of this? You put the 9. And it's always going to be that number. Whatever that number was on the bottom will always go here.
I learned. I know stupid stuff.
I'm sorry?
I'm sorry.
Oh, it's okay. I thought you asked a question. I'm sure that we're all going to have something where we accidentally share something that we didn't mean to. I had a student last semester that she took her test in her t-shirt and underwear and got up to go to the restroom, and it was quite embarrassing for her. She forgot that she was half dressed, you know, so anyway, I think we're all going to have to just learn some things like that the hard way. But anyway, all right, so are we all good with that? Let's, Justin's going to continue this problem, but we have to convert the second one over. So we had 2 1/4, and we've got to convert that over. So we're going to go 2 times 4, right, which is 8.
8.
And then we're going to add 1. So that's 9. We put that on top. And what number goes on the bottom?
4.
4. Okay. Now, that means, Justin, that this problem is really 13 over 9 divided by 9 over 4. And now, Justin, I'll let you take over. So what would you like to do first?
We would write it down that way.
Yep. So everyone, we're right here.
You could reduce the 9s, couldn't you?
Well, can you? What's the
mean, they-
operation between the fractions? What is the
Because we're dividing. We're dividing. We have to
divide.
flip before we reduce. Gotcha.
Good. Okay, good. I'm glad you did that. I'm glad Justin made that mistake. I'm going to call it a mistake, but this is where we want to make mistakes. This is where we want to learn. We want to learn right here, and then when we get to the test is when we don't want to do it. So because it's division, we can't do any reducing until after we've done the keep dot flip. So go ahead and keep dot flip.
So it'd be 13 over 9 times 4 over 9.
Okay. And now you don't have the ability to reduce anymore. And that's just the way it is. I mean, that's just the way this problem is. There's no more reducing. So now we just multiply straight across. 52.
2 over 81.
81, there it is. Okay. So we are out of time. Boy, time flies when you're having fun, doesn't it? So let me talk about the homework real quick, what I expect from that, because there's no way you can finish everything. So from our packet, page 9 is where the homework starts. I think realistically, the only problems you can do here are multiplication and division problems. So that means you should only be looking at number 5, number 9, number 12, number 13. And unfortunately, that's it. Okay. As far as the homework, that's all you technically can do right now. Everyone got that? 5, 9, 12, 13. And then what I would recommend you do, since we didn't really get to finish, is to go back and let's see, was there anything else here? No, that was it. We finished all of them, right? We didn't do number 8. I don't think we did number 7, did we?
No, because that was the one I was hoping I'd get, and then you
Yeah,
threw
that
the
was the one
curveball
that
at me.
was going for. Yep, tricked you. So, I mean, those problems that I've circled are just, you know, practice those, and then we'll come back. We'll have a full day on Tuesday, and hopefully we'll get, you know, up to speed and caught up. But for now, that's it. Make sure that you read the syllabus, and if you need me for anything or you have any questions, I'm going to leave right now. But if you have any questions, I have my office hours start at 11. So just go through the syllabus, click on that Zoom link, and I'll be in there to answer any questions. Is that good? Anyone got anything? Okay, thank you for your participation. Oh yeah, go ahead, yeah.
Sorry, can you hear me?
Yes, I can. I can hear you, yep. Maybe not.
I think her screen is frozen.
Okay.
Yep, I think you froze up.
So we don't need to like.
You don't need to do what? Hand
Can you hear me
anything?
now?
Send anything in?
Not today. I'm not going to collect homework. Yeah, there's nothing turned into me except the exams or any activities that we do in class where I want you to submit that work. But I will tell you, like, and I have to teach you how I want you to submit work. I haven't even shown you that yet. So for now, just be doing your work on your own paper. Keep it with you. Keep it in a folder or something like that. And don't worry about having to submit anything to me at this point.
So this is the homework, and we're going to go over it on Thursday when we come back to the class.
If you look at these problems that I circled here, if you have any trouble with them, then of course I'll start class Thursday, and I'll address any questions you had. Yeah. And then in the future, it will be a much bigger homework assignment, so I'm sure there will be questions. For this one, you know, y'all might get through this no problem. So it really depends on you. All right. Okay, thank you, everyone. Look forward to seeing you later. Just bail out.
Bye.
Bye.
Lord.